Okay. I'm not going to comment because the microphone is turned on. So. Okay. Just to review from yesterday, we talked about the atomic number. I have over here on the board, like this is what it looks like for your periodic table you got yesterday, just so you don't get the numbers mixed up. Okay. So the atomic number tells us the number of protons and the number of electrons. And it's the whole number, so you don't have to worry about rounding it. Okay. And we already did that question. Okay. So then for the mass number, that is the other number of the periodic table. So we talked yesterday all about the history of the atom, and Rutherford was the scientist that came up with the nuclear atom, where the nucleus contains the protons and the neutrons, because that's where the mass comes from. So the mass number has the total number of protons and neutrons in it. So it is the decimal number on the periodic table. But for our purposes, until we say otherwise next week, the mass number, you do not write down it as a decimal. You will round it because today, since what is wrong with my voice? It's the total number of protons and neutrons. We cannot have partial protons or partial neutrons in an atom to make a full atom. So that's really gross. You round the decimal number to whatever's nearest whole number. Okay. So like 5 or higher, round up, 4 below, keep it the same. Okay. Okay. So I have these here just so that we could practice one. We don't need to do both of them, I'm sure. But so to find the number of neutrons, you just subtract the mass number that has been rounded minus the number of protons, the number of electrons, or the atomic number. They're all the same. Okay. So which one would you rather do? What's F stand for? Who knows what that means? Fluorine. Fluorine. Yep. A lot of people accidentally put FL for fluorine and it's not F. That's fluorine. Anybody know what HG is? Its name doesn't match its symbol. Mercury. Yeah. It's HG because the Latin name was Hydragyrum, which stands for quicksilver. Mercury is a liquid metal at room temperature. So which would you guys prefer to do? We're only going to do one, where we're going to figure out the number of protons, electrons, and neutrons. Okay, we'll do mercury. Okay. Remember yesterday I had these symbols, the P+ for proton, the E- for electron, the N0 for the neutron. Okay. So on this box, the atomic number is on the bottom in the middle. So that would be the number of protons and the number of electrons. And then 200.59, I would round that to 201 because of the 5. So 201 minus 80 will tell us the number of neutrons. This is where you may need a calculator. I know it's Friday. Your brain might not be totally warmed up. Is that 121? Yes. Okay. Thank you. Awesome. Okay. So Do you guys remember doing this at any other point in your lifetime? Yeah. Eighth grade science, and maybe biology. I think your biology teachers would say that you would do it. You did it then, but yeah, it's okay. All right, now I'm gonna pause and explain the worksheet, but then we're gonna come back to the notes and keep going so you can finish the worksheet. Okay, so pause and go here. Okay, so on the worksheet, on this table, you are gonna fill in all the information. So even if you don't have everything, you could use the periodic table to figure out the rest. Okay. So the element is just like whatever the name is. Okay. So if you need to write this stuff down, you do it. Okay. So whatever element name it is, the symbol is the symbol, the letters. Okay. Now, the atomic number we just said is the same as protons and electrons. So I would like put a star or something above those three columns. So if you know one of the numbers from those three columns, then you're going to know all the numbers from those columns. So like where it says 17 for protons, that means it's also going to be 17 for the atomic number and 17 for the electron. Okay. And then the mass number, that's the one that's decimal, but on this paper, when you fill it in, you need to make sure that you round it. Okay, so you want to just make sure that you round for that, because again, we cannot have partial protons or partial neutrons when we're filling in this worksheet. And then the neutrons, you would subtract, I'm going to say Mn for the mass number minus An for the atomic number there. Okay, so now when it's the neutrons, there's actually two possible options for that element that you figure out. There's one somewhere else, but there's like two options as well. Either option is correct if you find it and fill it in correctly. But so when you're finding the neutron, just I start at the top because 6 is a very low number, and just start at the top of your periodic table and start subtracting the numbers until you find where it subtracts and gets 6. And then you know that's the element that you have. So do we have any questions about this section? It's pretty self-explanatory, not too bad. We'll have the answer keys so that you can check. And I think a lot of you are already doing it, so it doesn't matter. Okay, well, let's quickly go back to the notes just so I can be done talking today about this. And we're gonna keep going. This may be a chemistry pun at some point, so you gotta pay attention, I guess. I don't know. So the one element says, oh my gosh, I've lost a neutron. Don't worry, you can get a new one free of charge. Yeah. Okay. And then here's another one because we're starting to learn our symbols. Do I know a joke about sodium? Nah. Because it's the symbol of sodium. Anyway, so the thing that we need to talk about that makes atoms of the same element slightly different sometimes are isotopes. So the second point of Dalton's atomic theory, which said all atoms of the same element are identical, is not always true. Okay, we now know about these things called isotopes, which they have the same number of protons because protons are what makes the elements different. And if you change the number of protons, you're changing what element it is. But what makes them different is that they have different numbers of neutrons. So for example, I have sulfur here. Sulfur has 4 different isotopes that it could possibly have. Sulfur 32, sulfur 33, sulfur 34, sulfur 36. So the number here is the mass number. So this is just a notation of how you could show that it's an isotope. And so whatever the number is with this, that would be the mass number of that isotope. Okay. Now, like sulfur, what's the atomic number of sulfur? It's on the right side of the periodic table. 16. Okay, so sulfur 32 has 16 protons. And then to find the number of neutrons from when it's an isotope, you would just subtract from the mass number, right? So 32 minus 16 would be 16. But then sulfur 33, it still has 16 protons because it's still sulfur. But now the neutrons are 17 because if you subtract 33 minus 16, you get 17. So that's the only difference. It's all still sulfur because the protons would be the same for all four of these isotopes, but the number of neutrons is different. Okay. So another way that you could write this form, you could just use the element symbol and have a dash like that. That's a way to have isotope form. But another way that gives actually more information. Oh gosh, sorry, I forgot about this. I have another type of notation. So isotopes account for the decimal number when we have that mass number on the periodic table. It is an average of all the isotopes, and we're going to do that math next week, not today. But so when you see that sulfur has the molar mass of, atomic mass number of 32.064, that is an average of all four of these isotopes. Okay, so that's why there's that decimal. But typically we just round it for our purposes right now. So another way to show, this is just another example of an isotope. Carbon has 3 isotopes. Have you guys heard of carbon-14 before? Does anybody know what's that used for? Yeah. Know what carbon-14 is for? Yes, it's for carbon dating. That might be a chemistry fun too this year. So carbon dating is when they find a fossil and they want to try and figure out how old it is. Carbon-14 is very radioactive and it has a very predictable half-life, which means that it's the time that it takes for it to be halfway depleted from its original source. So carbon-14 is like, it's only abundant 0.0% of the time, and that's rounded significantly. So when they get a fossil, they see if they can detect carbon-14 and they try to see how much is there, because then they can mathematically calculate when did this thing die or when did this thing used to be alive, kind of thing. But so if you look at our periodic table, carbon, the number, the average is 12.01115. And that's an average because it's very close to 12 because carbon-12 is 98.9% abundant, meaning that most of the time it's that carbon. Okay, so this is where I'm trying to get to the movement. Okay, I don't want to do that. This is another notation for an isotope. Okay, so the X is going to be the element symbol, whatever that is. Okay, so you wouldn't put in X, you'd actually fill in the element symbol. Then the A and the Z, the A is always the larger number, and that is the mass number. So that should be a rounded number. Okay, so total number of protons and neutrons. So the protons plus the neutrons. Okay, and then the Z is the atomic number, or AKA I'm not spelling this nicely, the number of protons. Okay, so you will have some problems, and these are at the bottom of the worksheet, where I will give you some information, and you have to use that information to then write this isotope formula for that app. The tricky part is you have to be careful because sometimes the mass number that I want you to put for your isotope form is not the same as the number from the periodic table. Because remember, the periodic table is an average of a bunch of isotopes, but we're talking about a specific isotope, and so it might not exactly match. Okay, so I got 3 examples for us to try, just so you know what we're doing. Okay, so for the first one, we need to write it for an element that has 26 protons and 30 neutrons. So right away, protons tell you you can figure out which element it is. So which element has 26 protons? Iron, and the symbol for iron is Fe. It is not IR. People do that all the time. So you would have Fe as the symbol, okay? And then the 26 would be the bottom number on the left side. Then the top number is the mass number, but it's protons plus neutrons. So we would really need to add the 30 plus the 26, which would be 56. Okay, so that's it. Now, if you look at the iron, does it round to 56 from your periodic table? Yeah, yes, it's 55.8. So yes, technically that could round up, but it's just see how it might not be exactly that, and that's okay. Okay, so now let's make the isotope form for carbon 14. Okay, so this time I tell you the element is carbon. The symbol for carbon is just C, nothing else. Okay, so then the top number is going to be our 14 because that dash 14 tells us the mass number. And so then what is the atomic number of carbon? 6. So that would be the correct notation for that. Okay, so we get the hang of it? Know what to do? Okay, that's all we're gonna do today. We're gonna finish next week. I just need to finish making your answer key, but I've got the top table figured out. So I'll probably start with the bottom first on that and then help you. So that's all we do.